Okay, class, today we're going to look at the second day of partial fraction decomposition, cases 3 and 4. I'm going to have you begin with this warm-up, a review of what we did yesterday. Can you recall the appropriate setup for this particular type of problem? Okay, I hope you didn't have any difficulty with that problem. We're going to take a look at case 3 right now, which is non-repeated irreducible quadratic factors, and I mentioned that we're talking about the factors in the denominator. This is a linear factor. We learned yesterday that numerator will be a constant. This is a quadratic, and the fact that I cannot factor that makes that irreducible. So its numerator will be linear. Bx plus c is a linear expression. As we did yesterday, now we're going to multiply by the common denominator. We're going to multiply this term by that common denominator. And now I'm only looking at the numerator from here on out. It's simply a times the quantity x squared plus 4 because the x plus 1s cancel out. Now this term multiplied by that common denominator leaves me with needing to multiply the numerator bx plus c by the quantity x plus 1. I've got that set up, and then I'm going to distribute, which leaves me here with ax squared plus 4a. You can see I have bx squared plus bx and cx plus c. Now to solve this, I need to set up a system of equations. Again, we did this yesterday. I'm looking for my quadratic terms on the right. So I have a plus b, and I notice on the left, I do not have a quadratic term. That's why I have a 0 here. Then I look for my linear terms. B plus c, bx plus cx. Again, the left, there's not a linear term. That's why I have another 0. And then finally, I have a constant, two constant terms, 4a plus c. And I do have just a constant on the left, so this gives me 4a plus c is equal to 1. Now I can do this on my calculator if the calculator is allowed, or I can just do some work with this algebraically to solve this system. I'm going to start by saying A is the opposite of B. B is the opposite of C. That's going to lead me to conclude that the opposite of E is the opposite of C, and A is equal to C. Take a moment to look at that. Since A is C, I now have 4C plus C is equal to 1. 5C is equal to 1, so C is 1/5. Since A is equal to 1 to C, A is also equal to 1/5, and B is the opposite of C, so B is negative 1/5. As you recall, we started out setting this up as A over x plus 1 plus bx plus c over x squared plus 4. My A is 1/5. My B is negative 1/5. And my C is positive 1/5. I don't like that fraction in the numerators, so I'm going to rewrite that. I think this on the left is pretty easy to understand. Now you have to be a little careful here on the right because I'm going to take this negative, change this to a subtraction, put the 5 in the denominator because both of these are 5. Now I have just an x, but be careful, I have to have a negative 1 there because then this would distribute to get that positive that I had earlier. There's my final answer. I'm going to start you out with the second problem, at least I had started it out for you, and I'd like you now to take a moment to write out the system of equations that you will need to solve this one, or to write the partial fraction decomposition for this rational expression. Okay, so some success with that. We're ready to move on to some group work. Now that you've completed your group work, we should be ready to look on the fourth case, repeated irreducible quadratic factors. Similar to what we had yesterday, if we have a quadratic factor that cannot be factored, such as x squared plus 16, that cannot be factored, then one of the numerators is ax plus b. The second numerator is again a linear term, cx plus d. Multiplying by this common denominator, this numerator has to be multiplied by the x squared plus 16. This numerator needs nothing else. X cubed plus 1 then is ax cubed plus 16ax plus bx squared plus 16b, and then I've got cx plus d. I'm going to have an x cubed, an x squared, an x, and a constant. Those are just reminders that I need 4 equations. I've got 4 unknowns. Looking for the cubics, I'm going to have a is equal to 1. Looking for the quadratic, I'm going to have b is equal to 0. Looking for the linear, I'm going to have 6. Doing pretty good. I'm going to have 16a plus c is equal to 0. Now I know that a is 1, so c is going to be negative 16. And then finally, I've got my constant term. I've got 16b plus b plus b is equal to 1. Since b was equal to 0, that means b is equal to 1. Again, you recall I had ax plus b over x squared plus 16 plus cx plus d over x squared plus 16 squared. Now substituting, a is 1, b is 0, negative 16x plus 1, c is negative 16, d is 1. And one more time, we're going to change this negative here to subtraction, making sure that this would distribute to the addition here. Okay, that's the solution, the partial fraction decomposition for the rational expression that you were given. You've got a group work problem now. Give you a few moments to work on that. Okay, so welcome back, and as your final assessment here, I want you to select the correct setup for this last problem.